Hello and welcome to C# 103 Week 4. I'm going to be here and my name is Nelson, and so will Mr. Jason.
Hello.
And Mr. Gavin.
Well, hello there, Mr. Ed.
Kind of scary.
What? Okay, so today we are going to, as probably future people know, and as well as people in the class, I had a bit of an internet issue last Monday near the end of the class, so we didn't get to a few of the fun little operators that we're going to be doing today. So I'm going to go ahead, the first bit of this class is we're going to wrap up those operators. After that, we're going to jump into some other fun C# things to kind of cover some loose ends that I've sort of been kind of putting off teaching in class until we got to a more complex examples and a better understanding of code in general. So what I'm going to go ahead and do is I'm going to start off by implementing toDictionary. And remember that, and if I'm not mistaken, that's the last operator that I asked people to put together before we went on break last Monday, and nobody got to see my implementation for it. So I'm going to go ahead and toss that up right now. I'm not expecting people to copy it down, although we will be continuing that format for a couple of the additional operators we'll be putting together today. Actually, you know what? What am I doing?
I have no idea.
There we go. What? No? Give me 1 second. There we go. Okay, so let's go ahead and put together my toDictionary. So remember, my toDictionary is just, well, let's just go ahead and write it. So a dictionary requires a key and a value. And so my toDictionary is going to take in my toDictionary is going to take in a T key and a T value for the generic parameters. Now, the only overload that I'm going to go ahead and implement on toDictionary in this case is the kind of the simplest one of them, and that's just going to be this IEnumerable T. Or sorry, we need a T source, don't we? Because we need a key and a value for the resulting dictionary, but we also need a source for the source of the enumerable. So I'm going to add in a T source. I'm going to name this enumerable that, and then I think I'm also going to break my parameter list down so that we get a little bit more room, or maybe go into full screen. We might be able to stuff things in here. Okay, so the two things that we need is a key selector and a value selector. So for a key selector, what fits? What fits in this func delegate parameter definition for the key selector? So if I was to name this key selector, what are the generic arguments that we could place in that will sort of fit the signature? And we already got an answer, and that is correct. It's going to be the T source and the T key. Remember, knowing the generic parameters and the actual parameters, the function method parameters, and being able to sort of see how they can fit in and relate to each other is a very important skill. So because you're thinking in a really generic, no pun intended, sort of way when you look at a generic method. And so you kind of have to put the pieces together. So we know that we need a key and a value, and we know that the key selector and the value selector are both going to be taking in a source element and returning either a key or a value. So I'm going to go ahead and say T source and T value, and I'm going to call this the value selector. All right, so keep in mind that this is only one of the toDictionary overloads, and I'm not going to be implementing the overload that takes in the equality compare. And remember, we discussed a few caveats with the way I've been implementing these. First of all, we're not doing any
Sanity checker?
Yeah, we're not doing any parameter checking, parameter validation. Can anybody remember why we don't do any? Why we can't do parameter checking in the way that I've been implementing these methods? Right, but there's a specific word that I'm looking for. Well, of course, segfault got it. It's because of deferred execution. So that's the first caveat. We're not doing any parameter checking, even though the real methods do, and if you ever do find yourself implementing methods like this, you should do. And also, we're leaving out all of the equality compare overloads as well, because that's just a little bit of extra noise that doesn't really add to the discussion. But keep in mind that the majority of LINQ methods do take in equality compares, and they behave in certain ways, and you can play with that on your own. Okay, so now that we have our method signature, the actual execution of this is going to be very straightforward. We're going to instantiate a new dictionary of t-key and t-value. And then we're going to simply loop over each item in the source. And then we're simply, Then we're simply going to say dictionary.add key selector item, value selector item. And then we're going to return the dictionary. So that should be a fairly straightforward implementation. It's kind of like it's sort of like a select, but two selects simultaneously. Remember that a select takes in a projection, and this method takes in two projections. But now that we have this implemented, now I can do something like, I can create a class called class person, and I can say, okay, a person has a string first name and a string last name. If I had ReSharper, this would already be done.
What, no GUID?
Nah, no GUID this time. Go ahead and implement these guys, dump them on the top where they should go. I don't know why it generates them on the bottom, because that's kind of silly. And then I'm going to go ahead and create a people array, and I'm going to instantiate with like a new person of, Nelson, okay, and so on. And what I can do now is I can say people by first name equals people.myToDictionary. Now we can pass in the key selector. The key selector is going to select the first name, and the value selector is simply going to be the identity. And that's a math term that I hope most of you are familiar with, but it's basically going to be simply returning itself. And so now we have a dictionary of first names and last names, or first names and other people. So fun stuff. I hope this isn't too complicated or that complicated, or doesn't need that much discussion about it. I again want to point out, for people who have been following along, maybe they haven't really worked with generics before, but we have a lot of magic going on right here. For example, I'm just going to print this out one time, just as a small refresher. This code is equivalent to this code. And because of C#'s awesome generic type inference engine, we are able to shorten that considerably. So again, these parameters, this is what I find really interesting about this. These generic parameters are inferred because of the lambdas. The lambdas themselves give the generic parameters their type. For example, if I added a public int age property to my person, and then I wanted to create a dictionary of people by age to their people object, and I changed k.firstname to k.age. Notice how now, if I hover over people by first name, it's now if I hover over people.firstname, no ReSharper. Here we go. If I hover over MyToDictionary, you'll see that it's now returning a dictionary of int in person. The generic parameter actually changed because my lambda is now pointing to a different type. So a very interesting thing to sort of keep in mind when working with generic parameters. If you do things, if you write code in particular ways, you can generally get away with not having to specify generic type parameters at all. And of course, in certain cases, that's going to be impossible. In fact, we'll see an example of it being impossible very shortly here. But yeah, so that's toDictionary, and that's a quick recap of generic type inference. So any questions? I doubt there should be any questions, but if there are, don't not ask, because that's what we're here for.
That's right.
Okay, so I'm going to go ahead and ask people to go ahead, hit participate, fire up Visual Studio. Just to get the ball rolling, I'm going to go ahead and have people implement two very straightforward methods in LINQ that are incredibly important, even though they're very simple. And I decided to go ahead and start with these two because, to get people sort of warmed up back into the swing of writing awesome code. So the two things that I want people to go ahead and implement, and I'll explain what they do, although I hope that what they do should be self-evident by their signature. The first one is going to be cast. So a cast looks like this. The signature will look like this. IEnumerable, tResult, cast, tSource, and then we're going to just do this IEnumerable. Now, here's an interesting aspect of cast, and it has to do with the how we actually go ahead and can get away with not having to specify a variety of generic parameters. So, for example, I'm going to go ahead and write this out really quickly, then I'm going to ask people what's wrong with it. My keys stop sticking. Okay, so the behavior of this method should be fairly straightforward. We do .cast or .MyCast, and what happens is what we get yielded back to us, this is a deferred execution method, is every single item in that casted. But there's something kind of redundant about this signature, and it can cause problems. Not necessarily problems as far as not being able to use the method itself, but problems in that the call sites will be a little bit unwieldy. Can anybody guess why, given what you know about generic type inference, why this could be a problematic method signature? Okay, this is another very important. Remember how I said earlier, you really want your generic method call sites to be as straightforward as possible. So you'll notice that if I try to use this method, let me go ahead and dump this method somewhere. And then I'm just going to return null. It doesn't matter. If I attempt to use this method now, let's say I have a list of ints, and I want to cast this list of ints into an IEnumerable of floats. If I did this, floats equals objs mycast, notice how I have to pass in the source and the result. So our call site, actually, we can do better than that in our call site. There's no need for us to have to specify the source enumerable, because it could be generically inferred. But because the result enumerable cannot be generically inferred, it's impossible for tResult to be inferred because tResult does not appear anywhere in the parameter list. So how can we get this method signature down to only accepting the one type parameter that we want it to be converted to? All right, we've got one answer. And see, typically the Monday class isn't asleep like the Friday classes.
Yeah, but
okay, so what we want to do is to make this method, the call site of this method, more succinct. What we can do is take advantage of the fact that all generic IEnumerables, so if I jump to the definition of generic IEnumerable, notice how it implements IEnumerable, as in the non-generic type. Which means that because all generic enumerables implement that IEnumerable, and because our code here does not need to even know at compile time what the type of the source enumerable is. There's no benefit for that. We can shorten the signature of this method down to this. We can drop off the tSource generic parameter on our IEnumerable. Of course, this is going to result in me having to import using system.collections, because using system.collections is where IEnumerable is defined at. So I'm going to go ahead and import that namespace. That just popped a using statement up at the top of my file right here. And then I'm going to go ahead and just chop off this tSource generic parameter because it's no longer used. Now my call site simply becomes that.
Nice.
So it is taking advantage of the ungenericized version of IEnumerable, which is kind of nice, and it gets our signatures down, or our call sites down to only the information required. Okay, so now I'm going to pull up this this one. Where'd you go? I'm just going to copy this out. So we have our MyCast, and we're also going to have myOfType. Now, myOfType. Does anybody have?
You
what?
Correct the signature on that page for cast.
Oh, how did that not? I thought I could have sworn Wow, could have sworn I copied it over, but I didn't. Okay, so here's our MyCast and myOfType.
That's SafeWalk brings up a good point. What should this method do in the event of an invalid cast?
Well, what you're going to want to do is, well, throw an invalid cast exception.
It's my entire approach to exception handling. Is start typing words that seem related to the exception, and then wait for ReSharp to tell me what the available options are. There's millions of them.
Well, keep in mind you can take advantage of something, and we'll talk about that later. But I do want to point out MyCast may throw an invalid cast exception. In fact, it should if we are doing an invalid cast. MyOfType, however, should never throw an exception. Now, does anybody have any questions about what MyOfType does?
All right, then. I do. What does it do?
MyOfType...
Is it the same as type of?
No. MyOfType will return everything in the source enumerable that is of the type of the generic parameter passed in.
Ah, nice. Wolf, an invalid cast, something like taking in a string and trying to cast it to a list of bananas.
Or that, yeah.
Something where there isn't a cast available.
Okay, so is everybody good? I'm going to go ahead and hit everybody's reset. There's not a lot of people participating. That's kind of sad.
Participate!
Okay, I'm going to go ahead and pause the... And we're back. So, remind me what I said while we're on break that I wanted to say on video. Oh, right. Casts and oftype are surprising or deceptively simple, but they do serve quite a few very important purposes. Obviously, the first example that I showed with converting or batch converting integers to floats is interesting, but there's also another implication given their signature. Now, their signature, if you look closely, like we talked about earlier, uses the ungenericized IEnumerables. Neither the IEnumerables that these methods are extending, neither of these methods are extending the IEnumerable that requires a generic parameter. That has an important implication for legacy code, or code written by people who don't know about generics. So, for example, an array list, which we talked about, I think, last week or the week before, it implements IEnumerable, the non-generic version. And not only that, you'll also notice other things from .NET 1.1 that don't support the generic IEnumerable, as well as interop with maybe other platforms or languages or whatever. So what they allow you to do is, because keep in mind, the rest of LINQ requires a generic IEnumerable. And that's what both of these return. There are two avenues for converting a non-generic IEnumerable into a generic IEnumerable so that you can start using LINQ with it. So they, like I said, deceptively simple. I do use them quite frequently, but I also use them very commonly, and keep these in mind when working with legacy code that you want to be able to use LINQ with. So let's go ahead and implement it. MyCast is going to be straightforward.
You should totally make SaveQual do it. You should start going to people's, just picking people and making them do it on the screen.
I knew that, SegFault. I'm not that mean. Okay, so what a cast does is it loops through every single item in that, and it yield returns a hard cast. Now, keep in mind that I did say that this method should throw an invalid cast exception if it reaches an invalid cast, but we get that behavior implicitly through doing this style of casting. This style of casting, because we're not using the as operator, will indeed throw an invalid cast exception if it reaches a point that it can't, well, cast.
I was actually going to mention, I know we covered it earlier on in the C# series, but a brief thumbnail of the differences between is, as, and implicit, direct cast. A sort of review might be worthwhile, just in terms of how much more you've taught since we last discussed them.
All right. Well, actually, both the implementations for both these methods should actually launch into a discussion about that, because the key differences is they both iterate over the source. But what my_of_type will do is it'll say, attempted conversion equals, or attempted cast equals item as t result. If attempted cast does not equal null, return attempted cast, or yield return accepted. Oh, right. Well, this runs into a very interesting issue in regards to one of the things that we will be talking about later today, because we are going to be getting into what are they called? Structures. And we're going to be having to talk about value types and how they relate to generic type parameters. I know we kind of discussed that last time. But what we do instead, actually, or should at least do instead, is this. I'll talk about why this is later. Because if we didn't do it this way, we would run into the situation which we ran into before. I completely forgot about the different generic type constraints as far as classes versus value types, or reference types versus value types. But this implementation will work for both reference types and value types. Okay, so we've already actually seen three sort of things about casting. So conversions in .NET are interesting, or conversions in C#. We have implicit conversions. Like if I do float f equals 10, that's implicitly converting an integer into a float. We have explicit conversions, or casting, when I can do something like int I equals 10f, which obviously isn't going to work because there is no implicit conversion between floats and ints, but we can force a conversion through a cast. Now, keep in mind that a cast like this is only going to introduces the possibility of failure at runtime. So then finally we have the as operator, and the as operator is going to, again, the as operator really only works with at least in a genericized form. It's only going to work with reference types, obviously, like we saw before. But the as operator will simply return null if the item wasn't able to be converted, or it'll return the item if it can be converted. And then we have the is operator, which checks to see, is this item the other item? So this is not a generic. I thought you said this was a way of making it implied generic. I'm not.
He means the keyword this. Yeah, I struggle with that, and then I realized that's not a generic IEnumerable.
Oh, right.
I mean, Yeah, that this is not is a non-generic IEnumerable.
Right. But what it returns is a generic IEnumerable. Look at the signature. Signature, 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 signature. Look at the signature.
I'll go one better than that. Words, words, letters. Read all of it.
Okay, so now that we have both these, I hope nobody has any real questions about these. Of course, except for why the as operator won't work with this, which we'll get into once we start talking about value types, which we're going to be talking about later today. Okay, so now we're going to be taking a look at lookup. And I'm not actually going to have people implement this. This is one of two operators today that I'm not going to have people implement. And the reason I'm not going to have people implement this is because it will require the implementation of a class to fulfill a totally new interface that we haven't seen yet. So let's go ahead and look at lookup. If I wanted to go ahead and make a database of people, so var people equals new array, new person, I don't know, fine.
Gerald.
You know I can't spell that right.
It's phonetic. Sure, it should be first name Ra, second name Itty.
Let's think. Who else? I'm actually working hard.
Jason. You're so unimaginative. You struggle to think of the first one and then go, "Oh, I'll use my own name." And
well, no, I'm actually orchestrating this. I'm orchestrating this in a particular way.
For big band. Colgate is a toothpaste.
It's also a fan named Background Pony. Okay, so now that we have a database of people, what I'm going to do is a very common thing that you might want to do with a database of anything is to go ahead and group things by some sort of criteria. So what I'm going to do is I'm going to create a lookup.
Criterion.
Yeah. So if we look at the lookup method, we have a few different overloads we can use. We have one that takes in a key selector, one that takes in a key selector and iQuality compare, which we're not going to worry about, another one that takes in a key selector and an element selector, and another one that takes in a key selector, element selector, and compare. We're just going to worry about the key selector one. And what's the key going to be? I'm going to go ahead and say key first name at 0. And of course, you probably shouldn't write code like this. So what I'm going to do instead is I'm going to say k dot first name length is greater than 0, 0, otherwise empty character. Okay, because otherwise if the name had a length of 0, it would actually throw an exception. So what I'm going to get back from this method is what's called a lookup. In fact, I'm going to go ahead and write this out manually. I'm going to say it's a lookup of a character and a person, which you might look at and you say, well, this looks a whole lot like the dictionary stuff. We already kind of did that with dictionary, where we had a key selector and a value selector. And if you look at lookup, the signatures are very similar. We have key selector and an element selector, which is just the other terminology for
that.
Yes. Well, another question came in. I thought that when you got rid of tsource, you said it would be implied generic. I guess that just meant it would be returned as implied enumerable. No, when I got rid of tsource, I was able to chop off a one extraneous generic argument.
Extraneous. T-source, we know what it can work out what T-source is because, well, the source that you're passing in isn't a generic thing. It's going to, when you actually pass it in, it will be a specific type of thing. Therefore, you don't need to tell it to what the source is because it can work it out when you're passing it in.
Right, and no other member of any of MyCast or of my of type require the knowledge, the static knowledge of what type of IEnumerable it is, because both of them work on objects, and that's why IEnumerable returns as objects. But okay, so to lookup. So an ILookup, if we go ahead and jump into the definition of an ILookup, you'll notice some interesting things. ILookup, a generic interface, takes in a T key and a T element. It inherits or interface inheritance for IEnumerable of IGrouping of T key and T element.
Now, we haven't mentioned IGrouping at all, ever.
No, we'll have to get into that as well. You'll notice it also has a count, which is interesting, which actually carries an interesting implication as to how lookup works. Can anybody, given that the lookup returns an item with a count, even though lookup is an IEnumerable of something, but does have a count element on it, what implication does that give us? What hint does that give us as to the nature of the toLookup method?
Can I just say, one implication?
No, not that it's a list, but closer. And this is a question you should always ask yourself when working with LINQ. Does this method do this, or does this method do this? Because it's something that you have to be cognizant of all the time. Exactly, it's deferred. It's not deferred, sorry. We know it's not deferred already. Obviously we could look at the documentation on it, but we know that it can't be deferred because one of the members of it is indeed a count. So that's the first sort of clue we get while looking through this code. I could have just told you that toLookup wasn't deferred, but I kind of wanted to, if you're looking at something for the first time, jumping into the definition of interfaces and gathering from inference different aspects of it is kind of an important thing to keep in mind. So you'll notice it also contains this syntax. Did we actually go over that syntax at all? Ever?
What do you mean?
This.
What part of it?
This. Quite literally this. Okay. This is called
this Stop doing that, please.
You what?
There's no point in doing that. All it does is make the frame rate die.
Okay.
And it's really distracting.
So now if I jump back into program, let's go ahead and see what this actually did for us.
Wolf did ask, why do we know... Why do we know that it is not deferred from it having count?
Think about that. We know it's not deferred because it doesn't. A deferred method always just returns an IEnumerable. An IEnumerable is a sequence. The only way to gain or to know the count of an IEnumerable is to, enumerate it in its entirety. Of course, there are optimizations if what you're looking at is a collection, but regardless, the only way to know if the count of an IEnumerable is to enumerate it in its entirety. The fact that a count is available as a property on ILookup is a hint. It's something we can infer from the design. Now, it's not a hard, fast rule. For all we know, the lookup class that implements this could simply return 4 as count all the time. But it's something that we can sort of infer from the signature. We sort of realize that what we're looking at isn't actually a sequence. What we're looking at is a collection. And remember, all collections are sequences, but not all sequences are collections. So we know that if we do a .toLookup, we are effectively flattening the query. Remember how I talked about toList earlier? Where a toList can sort of flatten a query, as in it'll grab everything out of the sequence and stuff it in a collection. Well, that's what we're doing here as well. We're doing a .toLookup. So if I change the source of peopleDB, the result of toLookup will never change because the result of toLookup is a flattened view.
So does dictionary implement ILookup?
No.
Or does it not need to?
It doesn't. Dictionary implements... Well, remember, ILookup was introduced in .NET 3, and dictionary implements IEnumerable of key value pairs, whereas ILookup implements IEnumerable of IGroupings, which are different. There's a very important distinction, because let's go ahead and... Okay, so what's the output of this program? All right, let me go ahead and run this and see if people can sort of get an idea about what's going on. What we've done is we've effectively grouped. Doesn't clear up. Oh, am I chopping to anybody else?
Sorry, what?
Am I choppy to anybody else?
Not to me.
Huh. Okay, so what we have right here is we have a toLookup, and the toLookup method, what it did was it created a lookup based off our key selector. And what a lookup is a lookup is very similar to a dictionary, except with one exception. A dictionary may only associate one key with one value, whereas a lookup may associate one key with multiple values, which we sort of see right here. We're grouping our different people together by the first letter in their first name. Obviously, I mean, I hope people can see the use of this. It's very, very straightforward. And what we can also do is we can use this indexer. So for example, let's say I'm going to go ahead and just take this code. I'm going to dump it somewhere else for now, because there's two things that I want to talk about.
Actually, yeah, Segfault put a good way, which is that it's like an index in a book rather than a dictionary.
Well, yeah. So,
it's, you know, a list. Sorry.
Well, yeah, exactly. There's one more important aspect of lookups, and that's the indexer. So let's say I wanted to get people whose first name started with R. What I can do is say lookup R. Now I can say for each var person in first names with R, console right line person first name. And then if I change this to Z, obviously what we'll get is nothing, because there's nobody who starts with the first name of Z. Also, this is another instance where the string or the equality compares is very important. Let me go ahead and dump in a
yes, because if you put a lowercase r in there, it wouldn't work.
I'm going to go ahead and cheat. I'm just going to use the string compare. I'm going to do current culture, ignore case. And obviously that's not going to work because the string compare wants strings. And then I'm just going to convert these to strings. So, sorry, cheating a little bit. Okay, so now what I can do is if I added another person in, with a lowercase r, and I asked for a lookup with a lowercase r, and run this code, notice how we get all three of them. So lookups are very handy, very handy. Okay. Can anybody tell me what the output to this program is? There's one last point I want to make about toLookup versus toDictionary. What's the output to this program? So I'm going to call this dict, And then I'm going to say for each var kv indict console right line kv.key kv.value.firstname. All right, what's the output? Anyone? Think of all you know about dictionaries.
I've got Aretha Franklin in my head now.
You what?
I've got Aretha Franklin in my head now. Segfault, of course, jumped straight in there.
Well, if I go ahead and hit F5, we get a argument exception. Not a duplicate key exception. Okay, so yeah, so that's a very important aspect. If you think that your data set can return more than one values per given key, you'll want to use one of two things. You'll want to use either the toLookup or the GroupBy, and we'll be talking about GroupBys shortly. Okay, before we go on break, I will leave one more thing for people to implement. Is everybody good with lookups right now? Because lookups are incredibly awesome and useful. Not only do they allow you to do very fast searches on things by a particular key, they also are not deferred, which is something that might be a good thing if that's the behavior you're expecting.
Did you actually do the implementation of that one?
Nope, I'm not doing the implementation of toLookup or GroupBy today because those require a little bit of extra code that I don't want to spend a bunch of time writing. Okay, so yeah, let's go ahead and look at one more signature. Now this one's going to be scary.
Ooh.
I kind of feel bad for leaving people with this, but
Make them suffer. They make us suffer. Did that come out loud? Sorry, carry on.
Okay, so what we're going to be looking at is a join. The concept of a join is fairly... It makes a decent amount of sense, I guess, if you think about it in the right way. Okay, so let's go ahead and fire up my notepad window, and let's write out the actual signature of join. Now this is going to look a little bit intimidating.
Double N.
Actually, I'm just going to do that.
Aren't you missing a parenthesis, possibly?
As of right now, I am, but I'll fix
An
it.
opening one.
An opening one? No, that's on the first line.
No, before join.
Oh, why do I have the word join right there? Wow.
Well, yeah.
See, this, without syntax highlighting, this signature is getting a little bit difficult. So we'll have an outer and inner. We'll have a func of touter,tkey for the outer key selector, a func of tinner, and tkey for an inner key selector. Now then we'll finally have a touter, tinner, tresult projection. And then I also, in this case, I do want you to pass in an iQuality compare.
Dun, dun, dun.
Okay.
So what exactly are each of the bits of those? I mean, the names are explanatory to an extent, but
Okay. So
not enough.
So what we're doing here is we're taking in two IEnumerables. Okay? For each one of the IEnumerables, we will select a key. So for the outer IEnumerable, we'll select a key, and for the inner IEnumerable, we'll select a key. If they equal each other, then we'll pass in the TOuter and the TInner into the projection. And we'll use the compare to determine if the outer key and the inner key is selected. So for example, if we have a, if we do something like, let's say we have two data sets. We have a person, so a person has a first name and a last name, and then we also have another data set called salaries, and a salaries has a first name for the person, the last name for the person, and the salary. So now let's say that we want to get, we want to join these two data sets because they're not joined at the moment. At the moment they're distinct elements, but they both have keys that we can use to relate them to each other. So what we can do is we can say var salaries equals people join salaries. For the outer, we'll select O dot first name plus O dot last name. For the inner, we'll select S dot or I dot first name plus I dot last name. For the projection, we will select the person and the salary, and we'll simply return the salary dot salary.
Do you want to break them out the same as you did with the declaration?
Yep. Actually, what I'm going to do is I'm going to make this even better. I'm going to say P dot first name has a salary of S dot salary. And now what we'll get back is a list. So let's say that it was able to match up the combination of first and last names through string comparison, and then it'll return all the people with their salary by associating these two data sets with each other. Who wants to tell me what? Or me? Or who are you talking about?
In answer to Rowdyball's question, look at the question panel.
Oh.
It's to do with salt, not sales.
Huh?
Salary comes from salt, because you people used to get paid in salt.
People used to be paid. That's bizarre.
In Roman times.
Okay, so I'm going to go ahead and pause the video. Okay, and we're back. So let's go ahead and implement just a quick, naive implementation of join. So I'm going to go ahead and write it out. So it's going to be public. Just going to copy this. Okay, so the most basic naive implementation of join is going to look like this. We're simply going to loop through each one of the outer elements. Then we're going to go ahead and grab the key out of the outer element. So we're going to get the outer key. I'm going to say outer key equals outer key selector for the outer element. Then we're going to loop over each one of the inner elements. Then we're going to, well, grab the inner key by simply applying the inner key selector or inner key projection or whatever whatever terminology you want to use in that case. Then we're going to say if compare dot equals outer key and inner key, then we're going to yield return the projection on the outer element and the inner element. And of course I forgot to actually name this properly because obviously that leads to a conflict. So this is pretty much the most basic implementation of this method. Does everybody understand sort of what it does now?
It might be worth showing it in action.
All right, so I'm going to go ahead and I'm actually going to go ahead and give people IDs.
You just couldn't let it lie.
No, they'll be integer IDs. Don't worry. Then I'm going to go ahead and create something else, like let's say an address. And an address has a int person ID as well as an address field or property. Then I'm going to go ahead and give each one of these people an ID. So 2, 3, 4, 5, 6. Now I'm going to go ahead and create addresses. So let's say we want a new address, let's say Cloudsdale. And then let's give another address to the person with an ID of 1. Let's say, I don't know, stuff. There we go. And then let's also give an address to a person with an ID of 2. Let's say,
Wibble.
And then let's give an address to the person with 4, say something like that. And so now let's say we want to go ahead and join these two databases together and get everybody's, or associate everybody's person record with a possible address record. So let's go ahead and see how that looks like. So I'll go ahead and say our addresses equals peopledb.myjoin. Now for the outer, we're going to pass in addressDB. For the outer key selector, we're going to pass in o.id. That's the person ID. For the inner key selector, we're going to pass in i.personID because that's what we want to relate to. For the projection, we're going to pass in PA, and then I'm going to say an address for blank. I'm going to string format this up. An address for blank is blank. And then we're going to pass in p.firstname and a.address. And then for our key compare, I'm just going to simply pass in equality compare int.default. So now if I loop over this and say for each of our item in addresses, console writeLine item. And now when I run this, we'll get a nice little compiler error indicating that I cannot have the same property name as the enclosing type. So I'm going to change this to address string for now. And then, of course, I'm going to actually implement the constructor because, you know, that is kind of important.
It might help.
Okay, now when I go ahead and run this, you'll see that we have also done a very basic mistake right there, and we have another error because I renamed this property. Now when we run this, we get our expected output. We've effectively related two different tables together by a common key. So Danko,
Okay, now...
You what?
Oh, did you stop talking then?
I just started. What?
Yeah, no, it's just because quite a few people have been mentioning lag in BuzzNet, and then all of a sudden you didn't say anything for 5 seconds, so I thought you'd gone away.
No, I'm still here. Okay, so Danko says that his mind has exploded. Is that a good mind explosion or a bad mind explosion?
That generally means bad in the terminology of...
Oh no, he said it was. He said it was a good one. Okay. So are people kind of seeing what a join does now? All right. Are there any more questions about join? Because it feels a bit esoteric, but it's also incredibly important when doing operations on data that's related, but isn't related in an object-oriented way.
Also, when you're reading, like, the signature on line 253 and forwards, things like that, remember, whenever you see that go-to symbol, not go-to, but
Lambda.
yeah, turns into symbol. Yeah, it's just the same as there being a function call there, in terms of it's a, you don't need to, you read that, that's a one unit is what I'm trying to say. What am I trying to say? It becomes more confusing, like on line 257.
Right. Well,
if that was defined elsewhere, I mean, you could factor that out so that whole line was just a method.
Right.
Cool.
Yeah. So the implementation is, all we're doing is we're looping through the outer enumerable. We're projecting. We're using our outer key projection to grab the outer key out of each one of the outer elements. Then for every single item within that, we go into the inner element, or the inner enumerable. We grab the inner key, we compare the outer key with the inner key, and if they equal each other, then we yield the projection between the outer element and the inner element.
So, for instance, if you had you and all your housemates in that, they could all share the same address and it would be fine.
Well, you need multiple address records because in this case, the address has a person ID associated with it.
Oh, okay.
But there would be ways to sort of organize this.
Yeah, I'll shut up.
Okay, so is everybody feeling good with this? It's an intimidating method. It's one of the methods that people get really tripped up on LINQ. But once you see the deceptively simple implementation,
it is nice, though. I didn't know about it, and I've already got ideas for it.
Rowdy Bull is very goof. Okay, so yeah.
Any more questions about what we've covered so far? Anyone?
Confused on why compare is not passed? Compare is passed. The last parameter, last argument, I specify the equality compare of int.default. If I were to do this the LINQ way, I would have to create an overload. And the reason I would have to create an overload is that in this case with my join, an equality compare is required. But I can go ahead and show you guys what the overload would look like. If I wanted to go ahead and make this implementation look more like the join ones in LINQ. Now this is one of the overloads of join and LINQ, but another one looks like this. It's almost the exact same method. Well, it's an overload. Except for it doesn't take in a compare. And it simply returns my join with that outer key selector, inner key selector, projection, and then a equality compare of
Default?
tkey.default. So here's one of the overloads that's actually in LINQ. So this makes it possible for us not to have to pass in the equality compare if we don't want to, which we don't need to. I can go ahead and remove that parameter, or that argument now. Okay, so moving on. The next thing we're going to look at is GroupBy. So I'm going to go ahead and nuke all that stuff. Let's go ahead and take a look at GroupBy. I am not going to have people implement GroupBy. And the reason is because GroupBy is a little bit more complicated to actually write out, and I don't really want to spend time doing that at the moment.
Well, first up, what exactly does it do?
Well, a GroupBy is actually very similar to a ToLookup. So if I wanted to do the same thing, my same example before, I could do group equals people.db .groupBy, and look at the signatures. there are 8 overloads. The first one takes in just a key selector. Notice what it returns. It returns an IEnumerable of IGrouping of T-key and person. The next overload takes in an iEquality comparer. Of course, that's a very common thing. I'm going to skip over all of the overloads that take in iEquality compares because those are all basically implied.
Yeah.
So the important ones to see are the ones that have a key selector, the ones that have a key selector and an element selector, the ones that have a key selector and a result selector, the one that has a key selector, an element selector, and a result selector. And yeah, and that's all there is. So there's 3 things in a GroupBy. There's the key selector, element selector, and result selector. So let's do something fun. Let's go ahead and grab let's go ahead and grab a list.
Ones that aim in, get me the ones that end in Y.
Yeah, so that would be very similar to a lookup. So I can just use the key selector for that. I can say K goes into K.firstname, ends with Y. And of course, I'm going to use a string comparison of current culture ignore case. So what I have now is a very interesting, just basically a lookup. So now I can say console write line people.key, and then I can say console for each var person in people. Then I can say console write line, indent 0 person first name, and then maybe do person last name as well, and have to add in another thingy. And when we run this code, we'll see essentially a well, in this case, what we've done is we've grouped together by a Boolean as opposed to an actual thing. So you'll notice that in this case,
it's the right Boolean. It's done what we.
Yeah, it's done exactly what we've wanted it to do. We could swap it around a little bit, though. We could say K.firstname, and then we can get the last item out of first name. So I can do K.firstname.length does not equal 0, K.firstname at K.firstname.length minus 1, otherwise empty. And by doing this, we get a nice little error because I have to convert this to a string, which I'm not going to bother about. I'm just going to use a character. I don't care about casing at the moment. I'm going to go ahead and hit F5, and now we see all the keys. Everybody has been delineated by how their first name ends. So again, this is very similar to a lookup, but there's two important distinctions about a GroupBy versus a lookup. Can anybody guess one of the major differences? Right. This method is deferred. Now that has a few important implications. First of all, this method does not flatten the original thing. Second of all, if I were to do people db, at 0, or sorry, well yeah, at 0 dot first name equals whoa, you'll notice that now there is that item there. Because it is deferred, and because it is deferred, if we change the source enumerable, we get different results. But that also has other implications. For example, the query is not flattened. The next important implication is that there is no indexer. So unlike a lookup, which has an indexer and a count, a grouping has neither. There's no way for us to use an indexer, and there's no way for us to use a count, because it's all deferred. It all gets executed in terms of a iterator block.
But of course, there's swings and roundabouts, because even though there's 2 bits of functionality we don't have, because of the way it's set up with an iterator, you've got, presumably, I'm hoping you're heading that way, there is other functionality available to you.
Well, to an extent. I mean, the fact that it is deferred is nice in itself, but we also have a few other interesting things. Like we have our element selector and results selector. So what an element selector is it's just like what you expect with a dictionary element selector. and a lookup element selector. So I can say v goes into v dot first name. So now I'm basically selecting out a string, which means now that this is an error because these are no longer people. It's now a string. And you'll notice that we get an exception there because I chopped off a format string parameter. So now we get the same result. There's also an element selector. And an element selector, or sorry, a result selector. And a result selector is fun because it takes in two parameters. It takes in the key as well as an IEnumerable of whatever it is we're doing. So for example, I can go ahead and say key comma R goes into people with the last, or there are blank people with the people whose first name ends with 1. And if I string format this guy up, what we can do here is I can say r.count, comma, k. And so now what I've effectively selected out is no longer an IGrouping. That's a very important concept. See, previously we got an IGrouping. Without this result selector, the return type of this method is IEnumerable of IGrouping of char of and person. See, that's the return type without a result selector. But if I add in a result selector, notice how the result selector is now selecting out a string, which means we no longer get an IEnumerable of IGrouping of character and person. We get an IEnumerable of string, which means we no longer have a key property. But we can do this. And I get this result. Hold on.
There are one people and also apostrophe.
Hold on.
In whose.
Hold on.
Actually, not apostrophe, W-H-O-S-E. No. Wow, brain fail. Just not what you put.
Where's the apostrophe supposed to go?
Whose. No, it is a W-H-O-S-E, sorry.
That was pretty, yeah. So now when I run this, I get, there's one person whose first name ends with W, there are two people whose first name ends with Y, and so on and so on.
And there have been people talking about the set theory and the Boolean and the things like intersect and things we covered last week. And it occurred to me over the weekend, if you're struggling to get to grips with those if you're searching through sort of programming sites, have a play around in, I imagine Blender's got them, but I haven't tried to use them. But any modeling software, or in Photoshop as well, I would imagine has got them. Because the graphical implementations of Boolean operations in modeling programs, such as intersect, union, and so forth, they are the same mathematical operations, just applied to 3D objects. And conceptually, that might help those of you who are struggling to get to grips with it from this angle to see it from another one. End of intermission.
Well, I mean, I can't say much because I don't do 3D modeling, but... Okay, so how's everybody feeling about GroupBy? 3 things you need to keep in mind: the key selector, the element selector, and the result selector. Second thing you need to keep in mind, this is deferred. And actually, that's about it. So people super awesome at this point, because you guys are about to ask people to go ahead and implement some more fun stuff. Okay.
Shiny. Good night, Paul.
Good night. Hey, I was going to ask, Nelson.
Yes?
Well, how do we stand on time?
109?
No. I'm estimating. I mean, I'm trying to figure out before end of class. Another 45 minutes worth, another hour.
Yeah, I think about another 45 minutes should be good.
Okay.
Okay, so what we're going to be doing is, next up, we're going to go ahead and implement a few more LINQ methods. The first thing we're going to do is an interesting one. This is going to lead into a discussion about that we're going to be talking about a little bit later, and yeah, I really want people to try to do this and see what they come out what they come up with, because there is a very obvious way to do this, but it's probably wrong.
Okay, show us what this is.
Okay, so what this is going to be is this is going to be a method called sequence equals. So it looks like this, or sequence equal. Now, there are two implementations of sequence equals. My sequence equals, and then the other one, I do want people to implement the iEquality compare version. So the sequence equals will return true if the source sequence equals the second sequence. If you guys already know what caveat or what important thing that you're probably going to get wrong on, please don't post in BuzzNet. Okay, and the second method that we're going to go ahead and implement is a fun one. It's the one that I use quite a bit with tuples. And this one was introduced actually in .NET 4. It's called zip. And this will be the last method that we're going to be looking at in LINQ today. Given this signature, I'm going to go ahead and knock my font down just a tad. Maybe not bold. Given this signature, what do you guys think the zip method should do? Now,
Might be worth breaking that out, signature.
Yeah, I can go ahead and do that. Okay, so can anybody infer what zip does based off its signature? Read in the generic type parameters. Let me go ahead and dump this into Visual Studio so we can get some syntax highlighting in this. Because this is a very good skill to have when working with things like LINQ, which I've said many times.
You can put them both in there, actually. Could you drop the other one in there as well while you're at it?
Alrighty. Yeah, so people are coming in and saying things. Let me go ahead and just lead people through the signature. Zip takes in 3 generic parameters. First thing you should pay attention to: a t source, a t second, and a t result. It returns an IEnumerable of t result. So we can already infer from just this first line on 223. 223. I love that number. We can already infer from this line that we are working with something that's going to do some sort of transformation. Because we take in 2 generic parameters, but we also take in something called t-result, and we also return an IEnumerable of t-result. So we can also infer that this is probably a deferred method. The next thing we get is the first parameter, an IEnumerable of t-source. So we know we take in 1 IEnumerable of t-source. We also take in another IEnumerable of t-second. So we know that we're getting 2 IEnumerables that potentially have different types in them. Then we have a method that takes in a t-source and a t-second, returns a t-result, and it's called projection. Based off apparently...
Nelson,
Gavin.
running Steam in the background.
Nope. Not to my knowledge.
Okay.
Well, I am, actually. I didn't think I was. Let me go ahead and nuke it.
Yeah. Because that word was really bad that time. You went all silently and then just disappeared as well. So, could you start on zip, the signature of zip again, please? Because that's where it started to go.
Oh, I just got... all right, sorry to all the future people who will have to hear this twice. Okay, so what we have here is a method called zip that takes in 3 generic parameters. That's the most important thing. It takes in 3 generic parameters. The names of these parameters should be well named. However, keep in mind that we basically just have 3 types that can be anything. We return an IEnumerable of t results. So we already have a feeling that we're going to be doing some sort of transformation on data. So what's the data that we're doing the transformation on? Well, if you look at this, the only 2 pieces of data that this method takes in is an IEnumerable of source and an IEnumerable of second. So we know we take in 2 IEnumerables of different types. And then the third parameter is our transformation. What does our transformation take in? It takes in a source, a second, and it returns a result. So you should already be able to implement this just based off the signature itself, because there's only one way for us to go from this data into this data. Or one way that really makes sense. So what zip ultimately does is it takes in 2 sequences, it enumerates them both simultaneously, and for every item in both of the enumerables, it applies the projection, and it yields the result of the projection to the output.
Again, I think you're going to have to do a concrete example of this one before you code it up.
Alright, well I can go ahead and just show something real fast. This happens a lot in doing data transformation, any sort of data transformation. Let's say we have two unrelated lists that we know match up by length. So for example, we could have a notes list.
A, B, C, D, E, F, G.
No, I mean note like description or something like that. So from one database call, we get a list of notes, or from one web service call, we get a list of notes, and for the other database call, we get a list of people, and we want to zip them up together. We want to go ahead and say, this person has these notes. So I can go ahead and say var zipped equals peopledb.zip, pass in notes, and then for my result selector, I take in a person and a note, and I return a string.format of person named blah has this note, or has these notes, blah. And then p.firstname and and then n. So now if I loop through each one of these things and print them out and run the code, we'll get a exception because for some reason or another, our zip method returned null.
Are you using notes at any point?
Indeed.
No, I mean other than passing it into, you're not actually calling on it at any point once you're not actually calling on that parameter at line 273 at all.
Well, I am, because it's passed into the second parameter of the lambda. See, the first parameter is a person, which is from the people DB, and the second parameter is the notes from n. And then we combine it with...
How does it know that?
Magic?
How does it relate n to notes? Or am I just having a brain fail?
Well, it'll make...
I thought that was the source of your error.
Well, look at the signature. It's a person string projection.
Ah, okay.
And for one reason or another, I'm getting a null reference exception on...
Yield... Oh, no, it's not. Oh.
Give me 1 second. Oh, okay. If anybody can tell me why I'm getting a null reference exception, I will give you a cookie. An internet cookie. Come on, problem solving. Why would I be getting a null reference exception right here? What mistake could I have possibly made? What common mistake that happens very frequently when working with stuff like this could I possibly have made? Come on, guys, think. You get it, Gav?
I think so.
No, it has nothing to do with string.format or the parameters.
Is it line 275?
No, it's actually actually 273 kind of.
Well,
okay, so
has anyone come up with anything yet? I will tell you what I thought it was, and you can then laugh at me.
look at line 223. Look closely at line 223.
Show us your call again.
PeopleDB.zip.
You fool. You fool, sir.
Because of resolution of extension methods, this extension method actually superseded that from LINQ because it is closer in a sort of conceptual way than the LINQ extension method. Extension methods, when they conflict with each other, don't actually cause errors. So I'm going to go ahead and rename this. And remember, to make this code compile, I simply said return null. I'm going to go ahead.
Actually, that wasn't what I thought. If you go back down to your way you're calling it again, because you're not using a parameter. You're not using. Are you not using type? Oh gosh, what is it? My brain's lost the word. On line 273, you got people.d.zip without a generic type argument. Is that just because it's inferred?
Yeah, it's inferred. There are 3 type parameters that are inferred. But now when I go ahead and run this, with using the actual real LINQ method instead of the one that I wrote, which didn't implement, we get this. So we've essentially zipped up these 2 collections with this projection. If I remove a bunch of these, you'll notice there's a bit of a mismatch. There's 3 people and there's 6 nodes. But the behavior of zip is to stop when it reaches the end of either sequence.
Ooh, that's not... I can see how that could cause user errors to slip through.
Zip is something that I do use frequently for... I use it a lot in HTML scrapping. I use it a lot in relating web service calls with things. You have to...
Presumably you should use try catch with some sort of checking or length checking for that, because that behavior you just showed means that you're not going to get notified if you've forgotten to type one entry into a database list of 3,000 things.
Right.
You'll just end up with a database of 2,999 things.
True. So there are considerations to keep in mind with zip, but it does come in handy when through other means you can guarantee that the sequences will be the same length, or per the logic that you're trying to describe, you actually want the behavior of it stopping if either sequence ends. Okay, so is everybody good with what zip should do? And the answer is not return null, by the way.
Do you think they've got enough to implement that now?
I think they do. Remember, we have sequence equal, and we have myzip. So I'm going to go ahead and hit reset. Everybody's ready. Hit participate if you want a fun little challenge. And the list of participating people are going down. No, if you're already participating, don't hit participate if you want a fun little challenge. Okay, I'm going to go ahead and pause the video, and we're back. So let's go ahead and write these 2 methods out. I'm going to start with mySequence equal. The first one I'm simply going to write as an overload to the other one. passing in an equality compare of tSource.default. Straightforward. Now the second implementation is going to be a little bit more interesting. It has a very important aspect to it that you have to keep in mind.
Stop talking about that.
Sorry. I'm going to go ahead and, it has two interesting things. First of all, there is a very naive implementation that we could write, or we can do it a little bit faster. But what I'm going to go ahead and do is say, I'm going to go ahead and actually write out nested for each loops, but I'm going to write them out as actual invocations of the iterator as opposed to a for each loop, so that I can move them simultaneously. So I'm going to say var using that enumerator equals that dot get enumerator. Then I'm going to say using var second enumerator equals second dot get enumerator. Now there's a few different cases that we have to compare for. First of all, we have to make sure that that enumerator can move next, and that second enumerator can move next. But if both of them stop at the same time, that means that we've reached the end. So I'm going to go ahead and say something like, if that enumerator dot move next, and then I'm going to say, or if not that enumerator dot move next, and not second enumerator dot move next, then return true, because that means that we've reached the end of the collection or the enumerator. Then I'm going to go ahead and say
Does that get checked after the value comparison for the last in the sequences?
that gets check what?
Well, because moving, I may be missing something, but does that not happen? Right, say we're on the last one in the sequence, in each sequence. Move next checks whether there's anything after them. So basically this is checking that we have the same length
Oh,
of sequence.
no, move next.
It's not checking.
Move next doesn't return false if there's nothing after it. Move next returns false when there's nothing left. So move next will return false when both enumerators have been enumerated on. And actually, I think I'm having a slight brain failure at the moment because I just realized a bug with this code. Now, if you think about it, can you spot the bug?
Other than they're not returning anything outside of the if.
Well, it only checks one. So what I'm going to go ahead and do is I'm going to do a simple thing. I'm just to say second, or that has more items equals that enumerator dot move next. And then I'm going to say var second has more items equals second enumerator dot move next. So now if that has more items, or if not that has more items, and not second has more items, then we return true. However, if that has more items does not equal second has more items, then we return false, because we've reached a discrepancy in our collection. Now finally, I can say if not compare dot equals that enumerator dot current and second enumerator dot current, then return false. Finally, at the end of this, the only way that this could get through is if we have a situation where neither enumerator actually, there's no way for this to reach the end, because if neither enumerator has any more items, then this will be true. If one enumerator has at least one item and the other one has 0 items, this will return false. Otherwise, we'll continue the loop. So I'm just going to say return false at the end. Okay, so one of the most important aspects of this is this method right here. Why is this? Why is the compare needed? Why can't I do this?
Ooh, you're going there.
Oh, actually, I'm missing a loop, everyone. Thanks for pointing that out.
Yeah.
See, my brain completely failed me. Well, first of all, we actually do get a nice little exception right here, fortunately. But if we did something like... actually, yeah. This is a terrible example because we haven't constrained tsource to a class, have we? Okay, so this is a terrible example. But if this code compiled, if I added a generic constraint for, let's say, where tsource is a class, and then this code will actually start to compile, why do we need the compare instead of using the equality operators? Well, that's going to lead us into the last thing that we want to talk about today, which is the idea of comparison. Because per usual, the equality operators, when working with value types, or sorry, when working with reference types, compare reference and not the actual values within them. So we can't use reference comparison because that's not what we're looking for. We're looking to see if the compare decides that each one is equal. And we'll talk about that a little bit later once we get into the object.equals method. So then I totally botched the implementation of this. And again, it's a little bit confusing.
You could have made it more confusing. With nested ternaries.
Oh, yeah.
I mean, I'm just saying, people should be grateful that you did that much writing. It's just because you haven't got resharper to do it for you with Alt-Enter, isn't it?
Okay, so skipping off of my sequence equals, we'll get back to that once we start talking about compares. I just wanted to point out that here's an implementation that should work. If you follow the logic, we get that enumerator and the second enumerator. We check to see if they have any more items. If they both don't, then we return true. If they do not equal each other, then we return false. Otherwise, we keep on looping. And of course, the while loop shouldn't actually be in there. The while loop should be up here. Third failure. I'm bad at this game.
Wow.
Okay, so yes, I've botched that implementation. Let's look at a actual proper implementation of zip where I don't actually fail at writing simple code. Because
it would be nice.
Well, yeah, I mean, typically.
I mean, just for a change.
Just for a change. We'll see if I can write this properly the first time, because this is a really simple method. There we go. There's our simple method. So we grab both of the enumerators, we move them forward simultaneously by using a while loop, and then we simply project or use our projection to determine if or to take those two items from each one of the sequences and convert them into our t result generic parameter. Can't really get much simpler than that.
Very nice.
Alrighty, so moving on. That's all I really wanted to cover on LINQ. If people have things that they want me to cover with LINQ, just point it out, and not for this class because we're really short on time. And there's two things I really want to talk about. Two simple things I really want to talk about before we wrap up today. But go ahead and post in the forums if you guys have any more questions about LINQ. Well, we will be using these operators quite frequently in the code that we will be writing from this point forward. And if there are any other situations where I end up using an operator that we haven't covered, we'll cover it. I also know that I have not covered anything about IQueryable. Now, IQueryable is a very complex thing for a variety of reasons, one of which is that it actually doesn't take in lambdas per se. What it takes in are expressions, and there's a bunch of C# compiler magic that goes into generating those expression trees, which gets on a huge other topic. And then you also have to worry about query providers and all that stuff. We also haven't talked much about the query syntax, and that's because I typically use the method chaining syntax for everything. Keep in mind, though, that you can use the query syntax for selects, multi-select, or select manys, wheres, all the types of joins, and grouping, and a few other fun things.
Can you just pick a straightforward and give an example of each type of doing the same thing with queryable and with, just so people know what it looks like?
Well, we kind of already did talk about it for a little bit. Like, for example, if I wanted to select everybody whose name started with an R, I could say people equals from person in people DB where person first name starts with R select person, and so on. I'm not going to get any more complicated than that. Well, of course, we can do order bys, like order by person dot last name.
That's cool. I just wanted so that people could relate if they see that sort of syntax.
Yep. And all this syntax does is it gets compiled down to it gets translated into a chain of method invocations, and that's it. That's it. So this is equivalent to if I had written this. That is the equivalent code. Notice how I omitted the select. That's because in a query expression you always need a select. And instead what I did...
So it's kind of implied in LINQ, isn't it?
Yeah, if it's an identity select. If it's anything else, if I wanted to select like the last name after this, I would have to add in a select at the end of this to select out the last name. Okay, so we're going to wrap up with two quick discussions. First discussion is going to be on something really fun that I don't use very often, but is incredibly useful with LINQ. A little bit of a history lesson, though. Implicit typing was created for this exact feature. This feature that I'm going to show you was why implicit typing was created in the first place. What C# allows you to do is create what are called anonymous types. An anonymous type is a class that has no actual definition. So for example, I could say var wo equals new, and what do I get? Well, what I get is the C# compiler actually runs out and generates a class for me. In fact,
what's the tooltip for the var?
It should say anonymous. Yep, anonymous type. If I go ahead and compile this and run this, well, great, I don't have a decompiler on this VM. But if I were to decompile this, what's going to happen is the C# compiler is going to generate a unspeakable class for us. The rules actually in which the C# compiler generates anonymous types are very interesting. It actually reuses anonymous types. What it will do is, for example, well, I'm not going to get into how it does it. It does it with awesome generic type parameters. It keeps the executable size down, so on and so on. The point is that don't worry about actually the actual implementation behind it, but it is interesting. Worry about the fact that what we've effectively done is told the C# compiler to generate a class for us and then instantiate it. The way in which the C# compiler knows what properties the class has on it are through these settings, I guess you could say, which can be any arbitrarily named identifier. Each one of these things gets turned into an implicitly typed property. So for example, if I open up wo in IntelliSense, I get prop1 and prop2. You'll notice that prop2 is a string and prop1 is an int. It follows the same generic or the same type inference. There's some other important aspects of anonymous types. First of all, anonymous types are unspeakable. There is no way in my code for me to ever speak of an anonymous type, meaning there is nothing I could place right here on line 295 other than var. The only way to deal with anonymous types is through either implied generic parameters or through implicit typing.
Funnily enough, I was just wondering about that because I wondered if the tick was available as in the syntax to us.
Nope. It's all unspeakable. Next thing to notice about these types is they are all the properties are read-only. So, for example, I cannot set to prop1 because it's read-only.
Chipsys just asked a question that might take you way beyond this, but he did say, can you get the class back for reuse through reflection?
Yes, but never do that. And one of the reasons never to do that is the way in which the C# compiler actually reconciles anonymous types. It'll be very, very confusing to both yourself and to anybody else who might be reading the code. And not only that, it would be compiler specific and annoying and just not something good.
Wow. You really touched a nerve there.
No, I'm just saying that the whole idea of anonymous type is a very compiler-specific implementation, and you shouldn't ever try to access it through reflection. Although you certainly could. There is a type being generated or a type being reused. Now, the C# compiler the Microsoft C# compiler does reuse anonymous types on occasion, but it's not something useful to think about because that's an implementation detail. Whenever you see an anonymous type, this is the only time you will ever see that anonymous type. Period.
It's not something useful to think about because it will make your head explode.
Other fun stuff about anonymous types, the names can be implied. So, for example, if I had like a person right here, a new person, blah, blah, blah. If I wanted to create an anonymous type with a first name, I could do person.firstname. Notice how I don't do first name equals person.firstname. That's because when you assign an anonymous type property to a variable or to something else that you access through a variable, like a property, the name can be implied for the name that you used for that variable. So, for example, I could do first name 123, and that will work. Or I can just simply do person.firstname. That will result in this anonymous type having a property called firstname of type string. So that's the first.
Will it actually complain if you try to do first name equals person.firstname, or is it just redundant text?
I don't believe the C# compiler complains. I'm pretty sure it doesn't. No, it doesn't. But ReSharper will definitely complain.
You are typing too much. See that sorry, it's just it seemed related in some way to tuples and their silly naming. Is there a similar thing there?
Well, with tuples, you can think about tuples as sort of like lightweight anonymous types, but they're statically typed. Well, of course, anonymous types are statically typed as well. But
I was just literally thinking of the name the automatic naming as opposed to item 1, item 2, item 3 that you get.
Well, there isn't really any relation. With anonymous types, you can have as many properties as you want, and they can be any name that you want. The only thing is you get an automatic name if what you assigned in the property of the anonymous type has a name itself.
Tuples don't have that functionality.
No. Tuples will always be item 1 through item 9, I think. Second thing, and this talks a little bit about lambdas. What's the output to this program?
And Skype is causing lag on your end. We finally found the solution. Turn Skype off.
Skype is causing lag?
Yeah, with this Dylan logged in, and then all of a sudden the screen froze and everyone started complaining about lag.
I can try turning Skype off. Is the video back?
Yeah, it's back now.
All right.
It was obviously while Skype was polling. So what were we looking at? What were we supposed to be
I'm
getting the output off?
typing it out because I don't want it to conflict with anything else that I've written.
Ah, okay.
Okay.
It worries me when I can hear typing but not see typing.
What is the output to this program? Well, that's a bad name.
Not segfault.
Okay, we got some hey. We got some many issues. We got some security. Oh no, I was talking about Skype. Any more people have any guesses as to the output to this program?
Any more people paying attention to the class? I'm not talking about Skype.
Okay, if I go ahead and dump this program down into Visual Studio, we'll see something interesting. Now, this isn't necessarily an aspect of anonymous types, but this is an aspect of lambdas that you need to be aware of, and especially in the context with anonymous types. I've seen people try to do this before, and they don't know why it fails. Well, it fails for a very, very simple reason.
First question: what's the hover over message?
It says cannot assign lambda expression to anonymous type property, which is misleading, actually, and I'll talk about why that's misleading. Lambdas do not have types. There's no such thing as the lambda type. A lambda is a compiler time construct that can be, at compile time, converted into a delegate. There's no such thing as a lambda. Which means that, for example, now let's do a simple proof. Okay, so we know there's no such thing as a lambda. We can only access lambdas through delegates. So we know there has to be a conversion from a lambda to a delegate. Well, I have 4 delegates right here, and they all have the same signature. No parameters, return void. This is completely valid. You can have as many delegates as you want to have the same signature. What delegate type does the compiler convert this into unless we explicitly tell it? Does it convert it into an action? That would work. Does it convert it into a thread start? That would work. Does it convert it into a void 1 through 4? All of those would work. Lambdas do not have types. They must only be used in the context of a delegate, which is why we can pass them into parameters to methods, because the parameters to methods have a specific delegate in mind. In the case of implicit typing, and remember, anonymous type properties follow the rules of implicit typing, there's no way for us to do this. That being said, there is one way to actually get this to work, and that is to convert our delegate into or convert our lambda into a delegate, a specific delegate that matches the signature of our lambda.
Nice. Something I was fiddling around with the other day. I kept having to do that.
Yeah, and that's because lambdas just do not have types. If there's no way, if the expression that your lambda is in is not a typed expression, so it's either it's using implicit typing, the compiler has no way to know which delegate to convert it into. And if it can't convert it into a delegate, well, you can't use it because there's no such thing as a lambda at runtime.
Sweet.
Okay, so anything more about anonymous types before I get into why you would actually ever want to use them? Well, actually,
I can't remember whether I said this earlier in this course on video or not, but this is one of those areas where if you get hung up, as certainly I did when I first started using ReSharper, on trying to follow all its advice, you'll find yourself going around in circles over lambdas, delegates, and anonymous methods. Whatever you pick, it seems to me, it tells you to turn it into one of the other 2 options.
Yeah.
And it never quite makes its mind up. So that's just don't worry about that. Pick one that you like, essentially. I think really it comes down to that. If you, like you were saying about the query syntax or chain methods.
Yeah, whatever works better. And sometimes the query syntax does work better, even though I don't use it very frequently. Okay, so we know that anonymous types cannot cannot be named. So can somebody tell me how is it possible for me to write a method? In fact, go ahead and write a method with a signature that will allow me to pass in an anonymous type and have the method return that anonymous type. Remember, you can't name them.
Put it in Gistit in the webinar. If you.
Well, if people, I mean, is anybody going to work on this?
Send it, or rather, what I meant to say was, if you're going to put it in the webinar, please use Gist or Pastebin.
Well, I would hope somebody would work on it.
Well, I want a method that can accept an anonymous type and return that anonymous type. Remember, you can't name anonymous types. There's no way for us to name it. It's unspeakable.
There should totally be an unpronounceable one.
All right, well, Segfault got it.
This is an unpronounceable method.
This is the only way to accept a generic type parameter, the only way to return a generic type, or accept an anonymous type, and the only way to return an anonymous type. And the only way that we can do that is through generic type inference. So for example, I can say, hey, equals identity, and then I can pass in an anonymous type and say person.firstname. Well, what gets returned? My anonymous type. I've effectively threaded through an anonymous type through a method, which is really cool. But the only way that I can do that is with generic type parameters, as long as the types of those type parameters can be inferred. You notice how a few times I broke apart my methods and I included the generic type parameters explicitly? Well, it's impossible for me to do that with anonymous types. There is no way for me to explicitly identify the generic type parameters.
That reminds me very much of the Singleton pattern, funnily enough. It's that T identity T. Do you know what I mean? It's the static instance.
Huh.
Anyway.
Okay.
Just in passing, that's what it feels like.
So why would you ever need to use an anonymous type? Well, anonymous types were built for LINQ explicitly. And they work very well with a variety of things that you can do in LINQ. For example, let's say I wanted to go ahead and grab something. So let's say I want to go ahead and group our people. So I say people equals peopledb GroupBy, and for the key of the group, I want their first character in their first name. And then for the result selector, I want to do something fun. I want to get the key and the people, and I want to turn it into a new type. And then I'm going to say, okay, so let's turn it into count equals people.count average name length equals people.select p dot, or I can't use people. Let's just call this grouped. And I'll do p dot select first name dot count or dot length dot average, and then just leave it at that. So what I've effectively done is I've continued my did I use anonymous types earlier?
Stop reading BuzzNet in the middle of explaining.
What I'm doing is I'm converting my my query into an anonymous type, and what I'm able to do with that is I'm able to sort of write more complex queries. I can now go ahead and group everybody by the first character and their first name, and then for the element selector, I can grab out the count of all of that, and then I can also do another calculation like the average name length, and so on and so on. So, and then notice how, because of how Visual Studio works, we get IntelliSense. So when I do group dot, I get average name length and count. To make this even more useful, I could include the key. So first letter equals T. And now I can say console write line for people with the first letter of blah, there are blah and average at blah. It's a horrible horrible thing.
Shiny.
So anonymous types allow us to do this. We can use anonymous types for virtually anything. Furthermore, we can even query on anonymous types. So let's say, if, for example, I only want to get the groups where the average length of their name is greater than 8 or 7. There we go. So notice how, because of the implicit typing of all of our generic parameters, we can effectively thread this anonymous type, which you typically wouldn't be able to name, all the way through our computations.
Very cool.
So it allows us to do quite a bit of fun stuff, and that's really basically it. It just keep anonymous types in mind when you need to sort of create a tiny little immutable data structure for your computation. Also keep in mind that anonymous types are very useful when using LINQ to talk to databases. That's because the database LINQ providers can look at, okay, so you're constructing an anonymous type. What are the properties of the object that you're asking for? Oh, well, you're only asking for the first name and you're assigning that to the property on your anonymous type. Well, the select statement that we're going to generate to go out to your database is only going to ask for the first name. So it gives the ORM, or the object relational mapper, more information about how to generate its SQL queries.
Squirrel. So, is that in terms of subject matter, is that the last subject for today?
Yeah, that's all I was thinking about covering.
Do you want to just run through what the homework will be, and then you can stop the video and then do what we've been doing more recently, which is have some questions afterwards? I'm just thinking about video length more than anything else.
Well, what I really want people to do with homework is to, and I was going to do this last week, but I guess everybody got a week off last week because of, well, my internet dying. I want people to go over, let me go ahead and find it. I want people to read through this. This is obviously, I said this before in the last class, the blog series that I organized this class around. And as far as reading all of it, obviously you can skim through aspects of it that you are already fairly familiar with, but some things you will find interesting, well, assuming that you find C# interesting, is definitely check out like the IIlookup implementation, because we never actually went over that, nor did we go through a few other things. If you read through this, and these blog posts are fairly short, well, this one really isn't because, well, it's a long method, but these blog posts are fairly...
Depends how complicated. Yeah.
These blog posts are fairly short, and there's a few other interesting ones I really want people to go over, though. The ones I want people to focus on are the... because we already went through pretty much all of these already, but I want people to look at the GroupBy, the group join, the IIlookup, and the ordering. However, everything else should be fairly fun to go through, because there's so many little tidbits of information in this, because he actually goes out, he talks about the specification of LINQ. He talks about he compares the Microsoft implementation to the Mono implementation, to basically a lot of additional information I find fascinating that we obviously didn't have enough time to go over during class today, or in the last 3 weeks. And then, of course, he goes over the query expressions a little bit more in detail. So you'll find out about the query expressions for, I'm pretty sure he goes into GroupBy, doesn't he? Yeah, he goes over the group expressions, order bys, and so on. And it's a really fun read. And then, of course, the last bits are a little bit less important. I suppose. Optimizations aren't necessarily the most important thing that I want people to take away from it. But he also goes over IQueryable in a fairly cursory manner. But yeah. So this will be posted in the forums. Definitely have fun reading it, because I certainly did. And there's a lot of tidbits that you can pick up on. But again, the only things I want people to focus on are the things that we didn't get to implement during class, because we're pretty much done re-implementing stuff. Unless there's something that comes up where, I need to explain what an operator does, I might pull up the implementation of it. Other than that, we're pretty much done with that aspect of the class.
So it's just read, comprehend, and presumably you'll have a little question answering session at the beginning of the next class about anything.
Yeah, anything that people
had
difficulty understanding.
I will actually make an exception, because I want to mention this specifically on video anyway. I do always, normally on the homework threads, put a little message at the end saying, please do not use this thread for bug hunting and code discussion. And yet, as with all these things, people either don't bother to read it or they just ignore it. But for this week, I'm going to miss that out, because I think it would be a sensible place to have any discussion. And if you've got questions that you want Nelson to deal with in the next class, pop them in that thread there. If you're going to not be able to make it, that's a place where we can know to check. That is all from me ranting today.
Yeah, group by group join, ordering, and to lookup, and then at least look at the 41 how query expressions work, because that gets into the query expressions syntax a little bit. Or, well, that's the entire point of that article. But yeah, and then yeah, I didn't realize that it would that going through LINQ in this depth would take 3 weeks, but it did, and I hope people had a lot of fun. Okay, so I'm going to go ahead and stop the video at 2 hours and 1 minute. Wow. And so goodbye. We will see all the future people next week.
Bye, future people.